How does SVG handle accessibility? What accessibility accommodations does it provide?
You want to take that one? Well, actually, I was at the Graphical Web about a month ago where there was an entire paper on accessibility. So SVG is actually very good for accessibility. Specifics, you should look up graphicalweb.org, which is the site, and look up the paper by Doug Shepers, which goes into detail about how it deals with it. So it's actually very good for accessibility.
Yeah, I had a little bit of a personal experience with this. I had a project when I was working at Oracle several years ago, and we actually implemented accessibility through screen readers in SVG. It was much easier in SVG than other technologies at the time because we had all those elements that we could get to, like the description and title and all of cement, like descriptive content about SVG that we could insert, and that was harder to do, like in Flash, for example.
So my question is for Vincent. When Comet comes out, is Snap SVG going to be a part of the thing that drives that prototyping? Like, can I code my transitions and stuff like that, or?
No, it's separate. So actually Comet is a native app. So we will have extensibility mechanism, but it's separate. Snap is more tailored to actually go use when you if you want to manipulate some of the assets we generate. But it's a separate thing. Yep.
Thanks.
So when can I tell my company to upgrade Illustrator to get that new exporter? And or what version number should I look for? Because that's
okay.
awesome.
If you're a subscriber of Creative Cloud, the update will come in the next release of Illustrator.
Awesome. Thank you.
Hi. You guys both talked a lot about the much smaller file size for SVG. I was wondering if you could talk a little bit about differences in rendering performance between like a PNG and an SVG, because theoretically a very complex SVG would take longer to render, but possibly download faster than a PNG. And I'm wondering what things you guys might look for to sort of like gauge metrics on how fast. Like, at what point would you not use an SVG on a website? Is my question.
That's a great question.
Yep.
I'll have a little stab of it. Okay, so ping versus SVG, very good question. The GNOME window manager in Linux quite a few years ago switched from bitmaps to SVGs for their icons, for example, because they saw that it was actually faster to rasterize the SVG than it was to decompress a bitmap. So again, it comes down to complexity, and depending on the authoring of the content, there can be huge differences. Right, so for example, I dealt with a whole lot of assets, like I was doing a lot of IPTV stuff with SVG, and some of the authored content, the icons would have like 50 things stacked on top of each other, most of them obscured, and that was actually very slow to render because it was overly complex. So the authoring side of it kind of let the rendering side down. It depends heavily on the browser you're targeting. Like, for example, Microsoft Edge is a fantastically fast SVG browser. Like, so kudos to their implementation. All of their SVG goes straight to Direct2D and is fully hardware accelerated. The other browsers are not all quite there yet, but they're all moving in the same direction. So right now, your mileage will vary and it comes down to testing, right? You know, like if I've got a complex graphic, try it out in all the different browsers. If it's slow in Safari or Chrome or whatever, then maybe I'll switch to the bitmap and lose the scalability. But you'll find that will run fast in IE, and I think you'll find over the next 2 to 3 years, everyone is shifting to hardware acceleration for their entire back end. So this is one of those moving targets that there's no simple answer for.
Yeah. One thing I would add is that I think it really, first off, in my experience, it really depends on the type of content you're looking at. And yes, you could, like for example, people who do art in Illustrator will create extremely complex, art. So there are options. So first off, the art could be sometimes simplified to be lighter for web consumption. The other thing is that, like you said, right, there is the problem of transport from your server to the client, and then there's rendering on the client. And on the client, you have options. Like if it's something that doesn't need to be rendered all the time, etc., you could very well take something, render it off screen into a canvas, and then you only deal with pixels. So you're not carrying like a humongous DOM on the on the client machine if you don't need to. You just render it once and then you display it. The advantage of this is you could display it at whatever resolution you want. So you retain the kind of the vector nature of the asset you got. You rendered it once, so you have to pay that cost once, and then you don't have to keep re-rendering it on the client when, like, say, you scroll or you zoom in or whatever.
Right. Since cool. Thanks.
Hi.
Hello.
So in the near future, which tool should we really look forward to using to creating SVG timeline animation? Adobe Edge or Flash Pro, since right now, as you said, you can export SVGs.
Right. So for SVG, the solution we have is through the Flash Pro extension, because Adobe Edge actually animates div elements, and it actually can insert SVG images, but it doesn't animate SVG elements themselves, which is something that the SVG export from Flash Pro does. So it's actually a more intimate relationship with SVG and Flash Pro.
Thanks.
Right.
So another question about tools. What tools are available in Linux environment? Apparently, like mentioning tools are not going to orgware. So did you try to use anything?
For Linux?
Yes.
Yeah, Inkscape is available on Linux, and it does have SVG export.
Well, in fact, Inkscape's native file format is SVG.
Yeah.
So, yeah.
Okay.
And in fact, Inkscape's probably one of the best tools to use if you want to try the new SVG 2.0 features, because they're madly implementing ahead of the curve. So they're more advanced than the browsers themselves.
I've been using Smile to do some animations on my site, but I got
Great.
some. Sorry, what?
Great.
Oh, I love it, but Chrome's been giving me error messages in the console saying, switch to CSS, we're removing Smile, and I'm like, uh-oh. So I'm playing with Snap nowadays, but I'm just like wondering, what's the interface layer look like in terms of going forward, and what's going to be supported and what's not?
That's the big unknown.
Yeah.
So Chrome has had some noise about deprecating Smile for quite a while now, over a year, and it's one of these things where if a feature isn't necessarily used by much of the web community and the developer population, then it's a candidate for removal, just to keep the browser lean and mean. YouTube introduced the use of Smile only about a month and a half ago for the play control that I showed in my talk, which suddenly jumped its usage way up into the not to be deprecated state. So who knows what will happen in the future, but the more people that use it, the less chance it'll go. So right now it's sitting at about 2%. If you go to chromestatus.com, and which is actually quite above a number of HTML elements. So at the moment it's a complete unknown, but it looks nice when you press play on YouTube. That's all I'll say.
It does.
Yeah. Yes, I think Smile, it would be a real pity if Smile disappears. I think it's a great technology. It's of course, like any of the web technologies, right? It has its quirks and limitations, but I think it's wonderful. And the group that did it was really knew what they were doing. So it has a really powerful timing model, and when applied to SVG, it's great. Like for morph effects, it's extremely easy to author, and it's actually a complex thing to do. So I'm also hoping it stays.
Yeah.
I've got a two-part question. First one is there any planned support within the browser to be able to support GPU accelerated transforms within elements within a SVG? Because right now they're only 2D.
3D transforms or 2D transforms?
Well, they're 2D transforms and they're not GPU accelerated. So like within any of the elements with paths or polygons or anything like that, if you're applying transforms, it doesn't get dumped to the GPU.
Yeah, it's a separate layer. Yeah, at the moment, I don't think there's any work going on with that within Blink. I think the current work is to pass the entire DOM tree down to the GPU layer for GPU rasterization, so it would negate the need for actually layering. Because what you're talking about is like when you do CSS, the Z-index hack thing, and it ends up in a layer and it's accelerated. If the whole tree gets chucked onto the GPU, then that kind of is not necessary. And the problem with layering is that it chews up texture memory. So as soon as you try and, you know, get a layer for every single thing that's being transformed and moved around, you start chewing up your GPU memory, and on mobile devices, that's a killer, because then you just run out of GPU RAM. So the short answer is nothing today. The long answer is there is a huge shift to GPU acceleration of everything on the back end of SVG. So, for example, Canvas is fully GPU accelerated in Chrome now. So all of the paths and everything are all GPU rasterized, but it's not the case for SVG. So it's just a timing thing. And a big part of this is also the CSS will change property. So I don't know if anyone's seen that spec. It's CSS will change, which basically lets you go, hey, this thing is likely to change, or, you know, so it gives the browser clues whether or not to rasterize that into a layer to optimize transforms and all that kind of thing. So that will apply to SVG as well.
The last question is around scaling using Scale 3D. So I've noticed that there's an issue in Blink and Chrome and Safari where if you are applying a Scale 3D transform on an SVG, that it rasterizes at whatever original like 2D transform it was originally at. So if you're scaling it up, then you end up seeing like anti-alias bitmapped SVG, and it doesn't like reset itself.
I don't doubt it at all. But it'll be another one of the gazillion bugs that are logged against Blink and Chrome, right? So with anything like that, it's like engineers triage these things and prioritize them. So the more people that star that bug, the more likely it'll get fixed. All right, so it's like if you find it important, rally around, tweet to your friends, say, hey, star this bug because it will more likely get fixed.